Hi everybody, welcome back. This is Unit 11. We're going to skip over Unit 10 because I know we won't be able to finish it before our holiday break. So we're going to jump into acid, bases, and salts, which I know we can get done before we go away. So acids and bases are important to study because they're around us every day. Like acids are prevalent in our foods. So you eat tomatoes. Tomatoes have an acid in them. They contain ascorbic acid, which is vitamin C. Oranges have acid in them. You know, vinegar contains an acid. Hot sauce has an acid in it. Even things like kale and spinach and green leafy vegetables have an acid in them called folic acid, which is important in our health, our brain development when we're in utero, right? When we're babies and we're developing inside our mother's womb. Folic acid is important in developing our brain. Bases are also around us. Bases you'll find in ammonia if you use ammonia to clean your home, or lye or bleach is a base. Even soap that you wash your hands with is slightly basic. So they're around us every day, and it's important to know about their properties. So that's why we're going to be studying acids and bases. Okay? You have to know some of the general properties about acids, and so in your notes at the first section are some of the general properties of acids and some of the general properties of bases. And that's really just what I want to cover today. First of all, acids have a very sour taste. If you've ever sucked on a lemon or a lemon head candy, you've tasted the sourness of acids, right? That sour taste is really indicative that you have an acid present. So the sour taste in lemons is due to the presence of citric acid. Okay? Acids, you know you have an acid because acids, aqueous solutions, conduct electricity. What it means is when you dissolve them in water, they'll conduct electricity. So when you dissolve acids in water, they conduct electricity, and there is a name given for anything who, when you dissolve it in water, conducts electricity. They're called electrolytes. Gatorade's loaded with them, right? All that it means is if you took Gatorade and you tested it, it would conduct electricity. An electrolyte is just a moving charged particle in water that allows that substance to conduct electricity. Our body needs electrolytes. It needs to replenish electrolytes after we sweat, because when we sweat, we not only lose water, but we also lose those electrolytes. And so that's why Gatorade advertises to drink Gatorade after, a big basketball workout because you've lost electrolytes. You could also drink tap water. Tap water has electrolytes in it as well. It just doesn't probably taste as good. The stronger the acid, the more charged particles are produced in solution, the more electrolytes, and the better the conductor of electricity. So you can actually test an acid strength by seeing which one is the better conductor of electricity. Stronger acids are better conductors. And acids can be neutralized. If I have an acid spill here, or some of you, when you did the Penny Lab, if you remember, I think Ellen and Josh and David maybe, you all got acid burns on your fingers. If you get burned by an acid, you want to neutralize it with a base. So you can react an acid with a base. Not a strong base, because that'll burn you too. Just a weak base like baking soda, and that will neutralize the acid and actually react it away. And what it makes is salt and water. Oops. I think I have the language backwards. But acids react with bases to make salt and water. And this type of reaction is known as neutralization. And they are really just wife-swapping reactions. So if you take a look at what I have here, you have HCl, hydrochloric acid. You can recognize an acid because they always have H first. And NaOH, which is a base. Bases are metals with OH, okay? Acids have H first. We're going to talk about this in our next video, but while we're here, what they do is they switch partners. So the Na goes with the Cl, that's your salt, and the H goes with the OH. And another way to write HOH is H2O. So when you got that acid burn on your finger, Josh, I put the baking soda on it, and all it did was make salt and water, so there was no more acid there to burn you. Okay? It actually neutralized it and took away the acid that was causing the pain. So the same thing happens if I get an acid spill here. I have to neutralize it with the base. Acids, as we know from the Penny Lab as well, acids react with metals. Metals that are above hydrogen to produce hydrogen gas. Okay, we saw that on table J with our Penny Lab. If you recall on table J, here's your hydrogen gas. Okay, anybody above it, all of these metals react with acids. And that is a single replacement reaction. They kick the hydrogen out of the acid to generate hydrogen gas. Okay? On the pH scale, acids have very low pHs. They have pH values less than 7. And it's important that you know the lower the pH, the stronger the acid. We'll talk more about the pH scale later in the unit. But any carbonated beverage, you can see cola is up here. Carbonated beverages are actually more acidic than vinegar, okay? Lemon juice has a pH of about 2. Gastric juice, which is in your stomach, it helps you digest your food. It's hydrochloric acid. It has a pH of 1. Battery acid is very acidic. That's sulfuric acid. It has a pH of about 0. So the lower the pH, the more acidic the substance, okay? You can even see that cola is more acidic than tomato juice. Kind of crazy. Acids also cause acid-base indicators to change colors. Table M gives us the table of indicators. And if you notice on table M, what I want you to do is kind of draw a line here through the word to. The first color that's listed for the indicator is the color that the indicator is in an acid. So for example, in general, methyl orange will be red in an acidic solution. But in a basic solution, the second color is the color that it is in a base. Methyl orange will be yellow in a base. Phenolphthalein that we've worked with before is colorless in an acid, but pink in a base. Thymol blue is yellow in an acid and blue in a base. Okay? So the first color that's listed is the color in an acid. The second color that's listed in is the color it is in a base. So if you have a solution and you don't know if it's an acid or base, you can use an indicator. Put a couple drops of phenolphthalein in it. If it's colorless, it's an acid. If it's pink, it's a base. So acids cause acid-base indicators to change colors. Okay? In an acid also, there are a lot of hydrogen ions. That's really what makes an acid an acid. So this is hydrogen ion. And this symbol is hydroxide ions. Both are present in an acid, just like both are present in water, actually. In water, they're present in equal amounts. But in an acid, there are more hydrogen ions. The concentration of hydrogen ions is greater. You get more of these, and you have less of these hydroxide ions, okay? Some important acids are given to you. There's a reference table for that. I think it's table L. So if you take a look at table L, let me just make sure before you write that down. Oh, table K. If you take a look at table K, you will find common acids. And their formulas and their names, they're given in table K. So you can look there for some acids, general properties of acids. Okay, let's move on to the bases. I don't know if you've ever had your mouth washed out with soap, but it doesn't taste good. Soap is a base, and bases taste very bitter. Okay? It's how I lost my first tooth. I said a cuss word when I was like 5, and my mother took me upstairs and washed my mouth out with bar soap, and I had a loose tooth at that time, and my tooth fell out and went down the sink, and the tooth fairy never came to me. It was a very traumatic experience. Right. Yeah. I think that's why when you swear in my room, I make you wash dishes. Right? I'm kind of, it's a whole soap connection. Bases feel very slippery. I always know if I got a base on me because it gives my hands a slippery or oily feel. Okay? They are also electrolytes. When you put them in water, they generate charged particles, and those charged particles conduct electricity. And again, the stronger the base, the better the conductor of electricity. If acids react with bases to make water and salt, then the opposite is true. Bases react with acids to produce water and salt. It is a neutralization reaction. We know that indicators will be different colors in bases, and bases have a pH less than 7. Okay, excuse me. Bases have a pH greater than 7. And the higher the pH, the stronger the base. So there's a general pH scale, if we can just really easy. In general, the pH scale goes from 0 to 14, with 7 being neutral. Now, it is possible to have a pH slightly higher than 14. It is possible to have a pH slightly lower than 0. Okay? If you're in this realm, 0 to 7, you're an acid, where down here would be the strong acids, and closer to 7 would be the weak acids. Okay? 7 to 14 are the bases. Close to 7 is a weak base because you're pretty close to neutral, right? The higher you go, the stronger the base. Okay? And in bases, you have both present. You have hydroxide ions and you have hydrogen ions, but in bases you have more hydroxide ions than you do hydrogen ions. So the brackets mean concentration. So we would say the concentration of hydroxide ions is greater than the concentration of hydrogen ions. That's it for today, everybody. We will see you in class tomorrow where we'll do a little demonstration with acid and base conductivity, and you'll get your test back. Have a great day. See you tomorrow. Bye-bye.